Hello, everybody. Welcome to Java Programming 1. This is our first class. I have given the intro and other stuff part of our syllabus review video. Hope you guys have a chance to listen to that. First chapter, we are going to give an introduction to Java and give you guys get prepared to learn the language, at least the fundamental stuff needed to do some basic programming and all other stuff. What we are planning to have, as I described earlier, there should be 5 chapters part of this course. Each chapter will have its own lab sessions, and you will have the lab assignments from ripple.it, which will be sent out a request or an invite to go and do your labs. You should check your emails periodically. Just make sure to start on the labs, and each week we will have 2 labs or maybe 2 to 3 labs, depends on how the time is. We will have almost 10 labs for the whole class to complete. Smaller lab sessions, just make sure you guys are on top of it. If you have any questions, you can email me or ask for an appointment if you need any additional help. Okay. All right, let's go into the first chapter. So as I said, there's 5 chapters. First chapter is just going to give you an introduction to basic programming languages and what is some computer configuration in terms of hardwares, what is a numbering system, probably languages, programming languages or computers are using, and how program instructions are given to computers, what are the basic components or different pieces required to compile your programs or execute your programs. All that we will just go at high level in this chapter. So again, the textbook we are referring is Java Illuminated from Julie Anderson and Harvey Franceschi. Just make sure you guys have a copy of this. I think you can buy it from Amazon for a cheaper price. Just read the chapters, listen to the videos, do the assignments and homework in terms of the quizzes we have, and the final exams, which is a cumulative one, which is having 30% of your grade. So just make sure you are on top of all this, and make sure you do your work on every weekly basis, right, to complete all that. All right, just let's get started. Here in the first slide, this is the textbook. Just make sure you have a copy of that. So what are we going to cover in chapter 1, right? Chapter 1 is, just to give you understanding, is what is programming, what is basics of programming, right? Basic computer concepts, what are the hardwares involved, what is networks and all that, how data flows, or what are some processes running in a computer, how data being represented in computers, introduction to programming languages as a whole, not just Java alone. There are several other programming languages, right? I mean, so some might be different in terms of how it's structured, the syntax and the compiling or interpreter. All that features are used for languages, or programming languages are different, right? Some are object oriented, some are client server based, or there are different ways you can do programs. Introduction to programming, programming basics, program design with pseudocode. Pseudocode is, just to give you a high level explanation, it's just basic English like coding instruction, so it's not real code, it's not English in between, it's just someone can understand the code more plain English language, just for the purpose of understanding. Developing a Java application, how to write a simple program, using Java programming language, right? So as you know, Java is very wide, extensively used in the industry. have so many libraries, so many additional interfaces, classes, objects. But our goal is at least to get the basic syntax, understand it, how, you can structure a program, compile, run it. Okay, all that is part of our course for this first programming course. Okay, what is programming all about? Why it's so important, right? What do you know about it? Well, programming is, when you have computers, it just understands only one thing, it's binary, zeros and ones, right? Computer has to give some kind of instruction to do certain things. Like you want to have, a game system or a game application built on a computer. It has to give the instruction what has to be, given, or what it has to be done, when someone log in the computer and do, start the game, right? Or let's say someone want to have an order entry system um, for a retail chain, right? They want to have, when customer calls in, they can go to a computer, start placing an order, um, and finalize the order with the pricing information and the product details and all that, and then they can charge a credit card. All that is, part of an order entry system, right? That has to be instructed to a computer through a software or a program, right? So that's what is a program. A program gives, the computer understandable language, convert your English or Surrey instructions to the computer understanding language, right? So it creating an application, or anything like ticketing, chaos, game, restaurant ordering system, any of those things, you need a programming language. Programming is a science. It is um, it is, some kind of, you know skills you need to develop it. You have to learn the language. Syntax is one thing, but you have to be some more creative, understand the software practices and principles to really build that software, right? So you need to have the mind to assign, a software engineering aptitude to build a good program. Okay. Programming is also creative. It solves problems. Businesses will have a lot of complex issues encountering every single day. A good programmer will be very creative. He will come up with solutions. All on a sudden, either the CEO want to produce a report which he want to see how many rejections happened yesterday. A creative, a programmer can quickly come up with, he can understand the data flow, where is the data in the backend database, quickly come up with an algorithm to produce and build that program, and then provide to the CEO, right? So it is a creative task you are doing there. So what are the basics computer concepts, or what are the basic components there, right? Well, hardwares, you all aware of the central processing units, memory and storage devices. That is like the physical thing of a computer, right? It can, it's same for, laptop to a desktop to a mainframe to a big, huge IBM, AS400 machines, or big computers as well, right? So everything needs a CPU called central processing unit. All of these computers needs, that's part of their hardware. That's where most of the the work happens, right? The instructions, the computations, the processing, the data flow, all that part of CPU. Memory and storage devices. As computers take everything to the memory, and then the central CPU, execute the instructions part of that given to the computer, right? Memory can be like hardware, a storage device like your hard drive, or it could be a RAM, random access memory, where this closest to the CPU, where the instructions can be carried out. Okay. And then you need an operating system. Like, what is an operating system? Operating system is, there is hardware, there is, all those machines there. it has to give the instruction. Someone should tell, or this is a program. I have to, you have to execute this sequence to the other instructions we have. So there's a Word document to be opened now. The user want, to open a document. So the operating system manages all that. So maybe running several programs, opening up, a web browser and doing the browsing part, and opening up a Word document. So multiple things it can handle. So someone should manage all that. That's the operating system's job there. Okay. Application software is the real softwares, like anything from a web browser like Google Chrome, or even Fox, or Netscape, or all these older versions of browsers, to utility programs like your Excel spreadsheet, or doc files, or text files. All that is basically an application, a software built, right? And then can be a complex application software built for a banking system to the commercial banking services, or for the data entry system for a complex e-commerce website, maybe like Amazon's, right? Anything of that nature, when you built with this programming languages and databases and all these different components, it's become an application software. Okay. Computer networks and internets, we should be quickly looking into that. What are networks? You've heard of local area networks, LANs, and wide area WANs, and the internet, is another network with computers and servers and all that together, right? All right, let's move into the next one. Typical computer hardware components, CPU. You guys are all familiar with this. Central processing units, that's where most of the instructions of a computer get executed, right? That's a key area for a computer. Hard disk, CD-ROM, it stores instructions, data, so the program can be loaded into memory and executed. So there is main memory, there is persistent memory like hard drives and CD-ROMs and all that. Keyboard and mouses are pretty much like input device, so you can give instructions from a computer keyboard, or a mouse is used as an input device. Your monitor, your printers, or your scanners, or all that components, or that pieces attached to a computer, it can be considered as an output device, right? So you will have a CPU, hard disk, and main memories, and keyboards, and mouses, and monitors, and all that together will be your computer hardware, considered to be the hardware of a computer. But when you consider the typical design of a personal computer, like a PC, right, a desktop computer, you will have a CPU. Look at the system motherboard here. CPU will have different levels of memory. L1 cache, which is very close to the central processing unit, which is, where it's quickly accessible to the CPU. When it's closest to CPU, your computer is, have more speed, so if you have a big capable L1 cache, your computer could be faster than, if you have low L1 cache. Okay. So just make sure when you're buying a computer, L1 cache is important. That's where if you want to get high speed, CPU, the processor is important, plus the cache memories. Especially L1 cache is important. L2 is closer, but it's the next level of memory for a computer, and then the main memory, and then the far apart, the storage device, your hard disk, that's how the computer is configured. The motherboard will have all these cache memories and main memories, and your hard disk will have a persistent storage capability. Input and output, keyboards and LANs. Input device is considered your keyboard, your LAN devices, mouse. Your monitor, printer, LAN, so it's connected through a LAN, which is considered to be an output device. Okay.